Hey folks, this one we're starting chapter 11. It's just a coincidence, it's part 11, but chapter 11 is on area. So let's go ahead and get started. So area of trapezoids, you guys, we add the bases, the parallel sides, multiply it times the height, and somewhere in there take a half of that. So the formula goes 1/2 base 1 plus base 2 times the height. Okay, the area of a kite, if you know the length of the diagonals, then it's this diagonal times this diagonal, half of that. Same with the rhombus. It's half the product of the diagonals right there, okay? So same formula right there. If you know the length of the diagonals, then that's the area. Squares, okay, you did that back in grade school. Same with rectangles, base times height. And triangles is 1/2 base times height, okay? And don't forget, area is always in square units, okay? So inches squared, centimeters squared, whatever. Okay, so here we have a trapezoid, it looks like. I should have put the parallel lines on there and I didn't. But anyways, that's trapezoid. So the area is 1/2 um, 1/2 the height times base 1 plus base 2. Okay, you can do base 1 plus base 2 times the height and then take a half, whatever. Okay, so make sure you add those first and then, pick up a calculator, multiply it times 8.5 and divide it by 2. That's the same as multiplying by half, and you get that. So square units, okay, don't forget the square units part. All right, so here's another trapezoid right there. So this time the bases are 8 and 11 and the height is 10. Okay, looks like this is not drawn to scale very well. Anyways, because looks like that 8 is longer than that 10. And anyways, it's not drawn to scale, but we can still do the formula. So there it is. We get 95 square units. Okay, so here is a kite. I should have put the markings, these markings. In fact, I'll do that right now. So it says this side equals this side, and then this side here equals this side. That's the definition of a kite, is that the consecutive sides are congruent, okay? All right, so there we go. There's our kite right there. Now those markings won't be there. So 1/2 the product of the diagonal. So another thing about kites, you guys, is always on kites, this diagonal is bisected, okay? So if that's 9, that's 9. Also, you guys, that's a right angle right there. So these are all right angles on kites. Same with the rhombus, they're perpendicular. So that's 9, making the whole diagonal 18, and this whole diagonal is 22. So 1/2 18 times 22, okay, and 198, and we got units here, so meters squared. Okay, so this is a rhombus right here because all the sides are congruent, and if I could, I would draw this diagonal in right here, but that's what this 16 is for. And similarly, this diagonal right here is this 10 right here. So 1/2 16 times 10 is 80 inches squared, okay? All right, so this is a square because it's a rhombus with all the sides, and since one of them is a right angle, all of them are right angles, so 13 squared is 169 centimeters squared. All right, and then we did similar figures, you guys. So triangle PQR is similar to triangle XYZ. And the area of triangle PQR is 1,200 feet squared, and the area of XYZ is 48 feet squared. So what we do is we're going to find the ratio, which is fraction, find the ratio of the areas, and then we're going to square root that. That'll get us our scale factor, okay? So the ratio of the areas is 1,200 to 48, and that reduces to 25 to 1. And look at that, perfect squares. So that's the scale factor squared. So our scale factor is the square root of that, which is 5 to 1. Okay, and then so the scale factor is going to be the ratio of the sides. So we're going to put 5 to 1 equal to 50 to this unknown right there. Okay, so 5 to 1 equals 50, and you can make it x if you want, or make it a question mark. Whoops, I went too many. Okay, so cross multiply, 5x equals 50, so our unknown is 10, and always answer it in the context of the problem. So sides are in units. Okay, area is always square units, and everything else is in units, and volume is cubic units, and that's in chapter 12. a couple days from now. All right, so the perimeter of triangle ABC is 16 feet, and its area is 64 square feet. The perimeter of DEF is 12 feet, and given that they're similar, find each. Okay, so let's find the ratio of ABC to DEF. Okay, so we're just going to go 16 to 64. Where did I get 12 from? Oh, I'm sorry, you guys. So the ratio of their areas is you got to get their scale factors. Sorry, I'm going a little ahead of myself. And then we're going to square the scale factors, because remember, the ratio of the areas is the scale factor squared. So the scale factor with the perimeters is 16 to 12, which reduces to 4 to 3. So the ratio of the areas is 4 to 3 squared. So if we square that, that's the ratio of the areas, 16 to 9. Okay, so now let's find the area of triangle DEF. Well, if this is the ratio of the areas, and we know that the area of ABC is this one right here, this one goes on top because that's what the 4 came from, or that's what the 16 came from. Was from ABC, and so the area is 64. Just make sure you're putting it on top right there. So the ratio of the areas is going to be 16 to 9, and then we just set it up, cross multiply, and we get 36 feet squared. Don't forget to answer it in the context of the problem. Don't just write 36. About half my students will just write that, and I'll ding them on a test, you guys. Okay, all right, so circles, you guys, remember area of a circle is pi r squared, circumference is 2 pi r, or pi times the diameter, because remember 2r is the diameter right there, so these are equivalent right there. Okay, so sectors of circles that have central angle n, the area is your area formula, pi r squared, but it's n over 360. And then the arc length is your circumference formula, but times n over 360. Remember, the whole circle is 360, so if a sector is n degrees of it, then it's n over 360ths of the circle. So times your circumference formula for that arc length, and then times the area formula for the piece of pizza right there. So find the length of the red arc right here. Okay, so this is going to be 60 over 360, and then arc length is going to be circumference formula times 2 pi r. Okay, so 2 pi r, 2 pi, and the radius is 8 right there. All right, this reduces to 1/6 right there, and we can keep reducing, you guys. Whoops, I got a little carried away. And then so this reduces to 1/6, and then 6 goes into, this is 16. 2 goes into 6 3 times, and 2 goes into 16 8 times. So it's 8 pi over 3. So we should have put centimeters on there, you guys. So you can write 8 pi over 3 centimeters, or the textbook actually got a decimal. They did 8 times 3.14159, I forgot what goes after that, divided by 3. So that's how they got that right there, centimeters. Okay. All right, find the area of that sector. Okay, so there's that sector. So we're going to use area formula, 60 over 360. Okay, again, this reduces to 1/6. And I know 2 goes into 6 3 times, 2 goes into this 32 times. So what do we get? 32 pi over 3. Okay, so centimeters squared, because that's what area is, and I didn't get a decimal version on that. All right, you guys, hope that makes sense, and take care.